In this video, I am going to explain about Web Security Appliance or WSA for an organization to be able to protect its environment against web-based security threats. Security administrators need to deploy tools and mitigation technologies that go far beyond traditional blocking of known bad websites. Today, you can download malware through compromised legitimate websites, including social media sites, advertisement in news and corporate sites, and gaming sites. Cisco has leveraged several tools and mechanisms to help customers combat these threats, including Cisco Web Security Appliance WSA, Cisco Security Management Appliance or SMA, and Cisco Cloud Web Security or CWS. These solutions enable malware detection and blocking, continuous monitoring, and retrospective alerting. A Cisco WSA uses cloud-based intelligence from Cisco to help protect an organization before, during, and after an attack. This life cycle is referred to as the attack continuum. The cloud-based intelligence includes web or URL reputation and zero-day threat intelligence from the Talos Cisco Security Intelligence and Research Group. This threat intelligence helps security professionals stop threats before they enter the corporate network and also enables file reputation and file sandboxing to identify threat during an attack. Retrospective attack analysis allows security administrators to investigate and provide protection after an attack, when advanced malware might have evaded other layers of defense. A Cisco WSA can be deployed in explicit proxy mode or as a transparent proxy using the Web Cache Communication Protocol or WCCP. In explicit proxies, clients are aware of the requests that go through a proxy. Alternately, in transparent proxy, clients are not aware of a proxy in the network. The source IP address in a request is that of the client. In transparent proxies, configuration is needed on the client. WCCP was originally developed by Cisco, but several other vendors have integrated this protocol into their products to allow clustering and transparent proxy deployment on network using Cisco infrastructure devices like routers, switches, firewalls, and so on. This figure illustrates a Cisco WSA deployed as an explicit proxy. The following steps are illustrated in this figure. Step 1. An internal user makes an HTTP request to an external website. The client browser is configured to send the request to the Cisco WSA. Step 2. The Cisco WSA connects to the website on behalf of the internal user. Step 3. The firewall Cisco ASA is configured to allow only outbound web traffic from the Cisco WSA, and it forwards the traffic to the web server. The next figure shows a Cisco WSA deployed as a transparent proxy. The following steps are illustrated in this figure. Step 1. As you can see, an internal user makes an HTTP request to an external website. Step 2. The internal router R1 redirects the web request to the Cisco WSA using WCCP. Step 3. The Cisco WSA connects to the website on behalf of the internal user. And step 4. The firewall Cisco ASA is configured to allow only outbound web traffic from the WSA. The web traffic is sent to the internet web server. This figure demonstrates how the WCCP registration works. The Cisco WSA is the WCCP client and the Cisco router is the WCCP server. During the WCCP registration process, the WCCP client sends the registration announcement. Here I am every 10 seconds. The WCCP server, the Cisco router in this example, accept the registration request and acknowledge it with an I see you WCCP message. The WCCP server waits 30 seconds before it declares the client as inactive, engine failed. WCCP can be used in large-scale environment, and this figure shows a cluster of Cisco WSAs where internal layer 3 switches redirect web traffic to the cluster. The Cisco WSA runs the Cisco AsyncOS operating system. Cisco AsyncOS support numerous features, including the following that help mitigate web-based threats: real-time anti-malware adaptive scanning. The Cisco WSA can be configured to dynamically select an anti-malware scanning engine based on URL reputation, content type, and scanner effectiveness. Adaptive scanning is a feature designed to increase the catch rate of malware embedded in image, JavaScript, text, and Adobe Flash files. Adaptive scanning is an additional layer of security on top of Cisco WSA web reputation filters that include support for the Sophos, Webroot, and also McAfee. About the layer 4 traffic monitor. The Cisco WSA is used to detect and block spyware. It dynamically adds IP addresses of non-malware domains to database of sites to block. And after that, we have third-party DLP integration. The Cisco WSA redirect all outbound traffic to a third-party DLP appliance, allowing deep content inspection for regularity compliance and data exfiltration protection. It enables an administrator to inspect web content by title, metadata, and size, and to even prevent users from storing files to cloud services such as Dropbox and also Google Drive. After that, the next feature is the file reputation. Using threat information from Cisco Talos, this file reputation threat intelligence is updated every 3 to 5 minutes. And then file sandboxing. If malware is detected, the Cisco AMP capabilities can put files in a sandbox to inspect the malware's behavior and combine the inspection and machine learning analysis to determine the threat level. Cisco Cognitive Threat Analytics, or CTA, uses machine learning algorithm to adapt over time. The next feature is file retrospection. After a malicious attempt or malware is detected, the Cisco WSA continues to cross-examine files over an extended period of time. And then the next feature is application visibility and control. The Cisco ASA can inspect and even block applications that are not allowed by the corporate security policy. For example, an administrator can allow users to use social media sites such as Facebook, but block micro applications such as Facebook games.